Hi everyone, I'm Allison and this is Beyond OpenTracing. Hope everyone's having a great week at KubeCon. So I work for a company called Asteris in St. Louis, Missouri in the United States. We're a consulting company and we've worked with various firms. We're currently working with a very large financial company and helping them move to the cloud, specifically on Kubernetes. So let's get a level set for the audience. Who has experience with Kubernetes? Okay. There are fewer hands that went up than I thought, so maybe some of you are asleep or in the wrong place. So what about distributed tracing? Okay. And then structured logging? Okay, pretty good. So hopefully some of what we talk about today will be relevant to you. Currently, we're moving from monolithic architectures to microservices. And we want our business logic to be constrained to a context. And we need to make sure that microservices are communicating with one another. And we want to do things like handle infrastructure elsewhere. So a container orchestrator like Kubernetes. Since we're using microservices, not everything is co-located. We need to do things like create a load balancer. We need to maybe use a sidecar for logging, set up metrics collection and visualization, and some of these tasks for observability can be daunting tasks for some engineers. In the past, people have logged into a server and grepped for logs, but now you're using something like Stackdriver or Splunk for logging. So if we can bridge the gap between application developers and infrastructure engineers and get everyone talking together using the same language, I think we can make some improvements in the observability picture. So an issue is knowledge of system state is hard. You have multiple services creating events and logging. Services need to be aware of overall system state and what's occurring. So if we can use a common language, like I mentioned, we can have application developers and infrastructure engineers working together. And if we can do this, we're also enriching our data and turning the data into usable information. This may look familiar to some of you. So logging into a server and grepping for logs, maybe you're looking for an error or you're looking for some sort of transaction ID, but this could seem straightforward and easy. However, you could be looking through thousands and thousands of messages trying to find what you're looking for, and it could be, you're sort of looking for a needle in a haystack. So let's see if we can improve upon this. So that's logging. If we use structured logging, we can impose structure and limit verbosity. So we're cutting down on the unique values if we can do this. And some people might say, oh, well, there are so many observability tools, so that, that is kind of out of control. How can I bring it down and, really make things work together? So if we can agree on a structure that we want to use and use a grammar for our structured logging, how can we make it easier on operations, and how can we give them the visibility that they need, possibly without using big data tools, but to make it easier for them to use big data tools. And what if someone doesn't want to have to use Splunk or Stackdriver? Well, using an agreed upon grammar and structuring our logs in this way should make it easier for someone who maybe wants to do that as well. So I don't like seeing log statements like this. Store some data. What are you storing? Where are you storing it? It's not really giving me any information. So, and a failed transaction. What failed? How did it fail? And how do you query for open file or open file failed. What sort of data are you going to get back when you're looking for this? So let's see if we can do better. So if we can impose a format to our logging and use structure and use fields instead of raw strings, we can tie context, we can tie a transaction ID, or some error to an occurrence. And we can reduce cardinality. So limiting unique values is really important. And we can use just a few fields and limit to just the information we need to see. We have fewer columns in a database then, so queries are improved. We have faster lookups, and we can improve analytics and get to the information that we need faster. Are there any Go developers here? Okay, a few. So LOGRUS is a common structured logging library in Go. And you have the ability to set fields. So this is your structure. So I want to look at comparing raw text to structured logging. This first example is just a raw string. The second one is an example using LOGRUS and you use with fields. Implementation can vary from developer to developer in structured logging. So you would have to spend a little bit more time thinking about your structure. And structuring can also vary from developer to developer. So a team needs to agree upon semantics for this. But I mean, I think this is worth it. It looks so much nicer than raw text strings. And this is an example from LOGRUS. It's from their GitHub page. These fields will pay dividends down the road. Okay, so moving on to the event grammar. If we can model events with a grammar and use common components from language, this can help us all bridge the gap with operations and developers. So the examples I'm using English. It's common in the English language, but as well as others. So we can really use our data and turn it into information that we can then use much easier. So we'll have faster queries and improve our analysis. So these are the grammar components. Subject and verb are required, and then the different objects, direct object, indirect object, and prepositional object are optional, but they do give flexibility based on your needs. A subject is a noun. It's a person, place, or thing, and it performs the action. So going over each of these components, I'll be using these same two examples. Parker rolls the ball to Kennedy on the ground, and checkout service updates inventory service, t-shirt balance, and database. So in both of these examples, Parker and checkout service are the subjects. The verb conveys action. So Parker rolls and checkout service updates. Those two are the verbs, so rolls and updates. The direct object is the receiver of the action. So Parker rolls the ball, ball is the object, and checkout service updates inventory service. Inventory service is the object in this example. So they're receiving the action. An indirect object is also a receiver of the action. However, it occurs in addition to the direct object. So Parker rolls the ball to Kennedy. Kennedy is the indirect object. And checkout service updates inventory service t-shirt balance. T-shirt balance is the indirect object. The prepositional object is the object of the preposition. It's introduced by the preposition. So a preposition is something like at, for, or on. So Parker rolls the ball to Kennedy on the ground. Grounded is introduced by on. And checkout service updates inventory service, t-shirt balance, and database. So database is introduced by the preposition in. And these objects are available if you need more flexibility and need more information for your grammar and in your logging, but you don't always need them. But they're there, you have the flexibility to use them. So grammar log is a proof of concept logging library I created. It extends LOGRUS, so I'm using their structure in their fields and applying a grammar. So at the top you see I'm creating a new logger, and the first argument is commander. It's my originating service. So this is the subject. And the second argument is the destination for my logs. So your service is always going to be the same. You don't need to set the subject with every log you're creating. So we set it once here and also set the destination once. And then I'm using debug level. And this is a simplistic example. So commander writes event to Kafka. This is another way to call the logger using a variadic function. So you pass in only the fields that you need. So same example, and it's commander. So commander writes event to Kafka. And you can do this instead of calling each of the separate functions like verb and object. Okay, so distributed tracing. I'm using OpenTracing and Jaeger, which is a visualization for OpenTracing written in Go. So with distributed tracing, we can get a better overall picture of a system, and it gives us more context when it's used with logging. We can trace calls as they propagate through the system and see the services that were invoked. We see the time spent in each call, and we can pinpoint delays. This also helps us visualize sequential versus parallel operations. This is from the commander service that we touched on, and I'll be going into more details later, but I'm using cross-process tracing with extract, inject, and carrier. So I'm using the built-in text map carrier, and I'm injecting the span context into the carrier, and it basically carries so the carrier carries the trace state from one process to another, from service to service. And lower down on the screen, you'll see I'm using the event grammar. So I'm setting the verb, object, and indirect objects. And then I'm also setting the tags in OpenTracing. So I'm using the same grammar, I'm using the same verb, object, and direct object for the tags. So we're linking together the logging and OpenTracing. So this shows OpenTracing tags, and they have required parameters, a key and a value. A key is a string, and then a value can be a string, Boolean, or numeric type. And standard tags do exist, such as database error or such as database type or error. And then you have the ability to create custom tags, which is what I've done with the event grammar. So you can see that the tags for these spans are verb is credit, the object is account, and then the indirect object is 32. So going beyond OpenTracing, we're able to get context through OpenTracing. We're able to get a better, bigger picture and overall insight into what's occurring. And using the OpenTracing tags, we're taking advantage of the tags and using the event grammar here as well. And we're using the same language with service logging and events, and also with OpenTracing. And we have the ability to search on these tags. So using an agreed upon semantics for application developers and operations, we're able to facilitate speaking the same language. And we're structuring our data to be analytic friendly. Using just a few fields, our queries are faster, and we're limiting the unique values and reducing cardinality. So with microservices, we need bounded context for our services. And the way I'm enabling services to communicate is event sourcing. So a service will publish state change events, and then any other service that's interested in these events can subscribe to that topic, so they receive all updates. And another really good thing we get from this is an audit log and overall application state, and we do get the ability to replay these events. So for my proof of concept application, I'm using CQRS, which is Command Query Responsibility Segregation. I'm breaking up the services by their business logic, and I have an Nginx proxy. The commander sends write requests to Kafka. The processor takes the requests off of Kafka and processes them, writes them to a database, and then the query service is able to quickly query due to the processor having pre-processed the requests. So a setup like this is optimized for write-heavy and read-heavy workloads. So we have a queue, the commands can just keep coming in, and when the processor can process them, it takes them off of the queue. But this can introduce latency, so we'll look into this. All right. So in the left pane here, I'm starting up everything with a clean slate. So I'm cleaning out Jaeger, cleaning out Kafka and Zookeeper. And while this gets started, so I started off, I wanted to have everything running in Kubernetes. But with a 9-month-old and a almost 3-year-old, things got a little hectic. So just use your imagination. I'm running this locally. Okay, I cannot see. I cannot see what I'm typing here in the terminal. I don't know what's going on. I don't think so. It shouldn't be. So I'm going to start up the applications. So I'm starting up the query, proxy, and commander. And I will start up a processor. Okay. So again, whoops. Here's the architecture. We have commands coming in from Commander onto Kafka. The processor is taking the requests off of Kafka, and query is querying them. So I'm going to go ahead and put a request on Kafka from the commander. The action will be to credit the account for this amount. So here's the response. We get back an ID. It was put on the commands topic. and the status is created. Okay, so you can see here the commander is the subject, verb is credit, and object is account. An indirect object is the amount that we used. And the processor is using the same language. So processor credits account 100. And I'm going to create a bunch of traffic. So I'm going to put 300 requests on Kafka. And let's look back over here. You can see them all coming in. Also, I'm using someone else's computer today. My computer broke this morning, so. All right, so let's take a look at Jaeger. So look at the commander service. We can search for the credit, verb equals credit tag.
Missing an I.
Sorry?
You're missing an I.
Ah, thank you. That wouldn't have worked well. Okay, and let's look at 300 traces. So, in the beginning, things are moving pretty quickly, and you can see we're really, really slowing down. So, over 30 seconds for some of these requests to go through. Okay, so I have the Nginx proxy, and then we're going through the commander. And again, I'm using cross-process tracing, so we're stitching together these spans to create a trace from service to service. So the proxy is going through the commander, and we're using those verbs, or we're using the tags for the grammar. So verb is credit, object is account, and indirect object. Same thing with the processor. It's reading from Kafka, and then it's persisting the request. So let's take a look at one of these that are taking a long time. Over 35 seconds. And it's taking so long that you almost barely see the span. It's tiny. Look at all this latency between the commander and the processor. But it's working, right? It's eventually consistent, but things are slowing down. So let's see if we can make some improvements. I'm going to spin up 5 processors. You can see them all starting up. And let's do the same thing, generate 300 requests. You can see all the processors are handling these processes, or reading from Kafka, handling the processing. Okay, so let's go back to Jaeger. We'll still search on that tag. And let's look at 600 traces. So this is the original with 1 processor, and then this is with 5, way on the right. So considerable improvements. About 156 milliseconds. So we were able to see that using distributed tracing, we were able to see that we had a lot of latency in the system. And, I'm only crediting the account, but let's say we had, debits to accounts or other operations that were occurring, and maybe it was only happening with one verb. That's something that you can pinpoint. You can look at that in your logs, you can look at that in OpenTracing, and really zone in on what the issues are and where things are happening. So, same tags here. So using this defined event grammar, we have an agreed upon semantics for operations engineers and also application developers to use. And using cross-process tracing allows us to inject the trace context into a text map carrier. And doing this, we're able to get a better overall picture. We're bridging the gap between application developers and operations and getting everyone speaking the same language. So application developers are able to gain insights on what they do in their code and how it affects observability and how it fits into this bigger observability picture. And we're tying OpenTracing to events and logging. So using structured logging with an event grammar, I think, is much better than raw strings. We're getting better, more useful information. We're able to filter it. We're enriching this data, and we're reducing cardinality. So we're really cutting down on the unique values that we have, and we can filter on things using this grammar and using tags. We're reducing cardinality. So fewer unique values, and we can improve analysis. So we have faster queries, better storage, and we also have the ability to set up things like machine learning and really enhance that. Thank you. Does anyone have any questions?
Do you feel like sometimes perhaps the structure that you've chosen is too limiting in some circumstances, and then you need more fields than the ones you came up with first? Or does it really cover it and you just need to choose a different verb or a different, I don't know, component?
Okay, so the question is, do you feel like the fields you've chosen or the structure that you've chosen can be too limiting? And do you maybe need to just add a verb, right?
Yeah, or do you just then have to change the verb for another one?
Yes.
Adding more fields.
So definitely, you change the verb based on whatever action you're performing. So if you're writing to a database, your verb would be writes. If you're issuing a command or it basically just depends on whatever the operation is that you're doing.
I guess the case would be if the preposition word itself would be, when you think about the natural sentence, would be to or from.
Mm-hmm.
That will make it different, right? And you don't have the preposition itself as a field, because that will be superfluous in most cases. But when there's an ambiguity, then what's your recommendation?
Right, so you definitely always use a subject and a verb. So that's the main, the meat of what's occurring. And then the objects are there as additional fields if you need more context or if you need more details. So the object is the receiver. So if you have a service that writes to a database would be the object. And then if you need more information, then you use the other objects for that. And yeah, it just changes based on whatever you're doing.
In Jaeger, if you could show that again.
Oh, sure.
It seems like you get the subject for real, but to the commander create command.
Right, yes.